Good afternoon. How you guys doing? Hi, Sean. Happy Monday. And it looks like maybe the sun's trying to peek through a little bit. It's been raining all day. All right, what's on tap for this week? Well, we're going to be talking about material that's in Chapter 8 of the textbook. And we're going to look at that, and we may not look at everything in Chapter 8. There's some, let's call them bells and whistles of ArcGIS Pro that are presented in Chapter 8. I don't know, they got questionable utility, especially if you're just starting to learn about GIS. But it's neat. It's neat to show off some of this functionality, things like making animations and making a data structure called a time cube. Sounds pretty funny when you say it. So we're going to be working through that, but I want to start today by talking a little bit about what your next practicum exam is going to be like. So let's do that. Why are there only 8 of you? Where the heck is everybody? I should just one day just stop posting these lectures on YouTube after the fact and see if that brings people back to synchronous learning. Anyway, all right, let's do this. So I was thinking about your next practical exam, and I came up with a framework, and it goes something like this. I'm going to pose 2 questions to you, and you're going to have to use GIS and use some analysis tools to answer those questions. And I will supply you with the data as well. All right. And while I was thinking about this, I was like, this is definitely going to be a part of your end of semester project as well. The end of semester project difference will be you get to choose what data you work with, but I will definitely require that you use one or more of the analysis tools in ArcGIS Pro to carry out an analysis that then answers a question. So you'll have some question and you'll ask that question of your data and answer it. That'll be the goal. Hi, Cole. All right. So let's go to ArcGIS, and I'll tell you a little bit about what I have for you for your second practical exam. All right. And why don't we start on Sakai. And let's see. All right, there we go. Alrighty. Okay. Sakai, here we come. Just gotta put in my password. Don't make any mistakes. Oh. There we go. Hi, Sarah. Hey, Sarah, I got your email. I think it was you who sent me to me. I'll take a look at that after class today and get back to you. All right. So I haven't posted this yet. It's just there's a draft form right now. But let's take a look at the draft form of Lab Practical 2. So this isn't until November 5th, so it's still a few weeks away, 3 weeks away, and 3.5 weeks away. But just like last time, I'm going to give you the framework for this so that you can practice before the time comes. Because I want you to do well. It's a performance assessment. It's an assessment of your ability to perform GIS. Of course, in order to perform and get good at it, you practice. So of course you can practice this before you come. All right. So I'm going to supply you, and we're going to take a look at this a little bit. I'm going to supply you with a project package. All right. And it's a little different than last time. Last time I gave you a map package, and I gave you separate data tables to join to the the layer that was in that map package. I'm going to provide you with a project package, and you open this package. You'll be able to download it from Sakai or ArcGIS Online. I'll be able to post it to ArcGIS Online as well. And this project package is going to contain a couple blank maps and a geodatabase that's going to contain 3 feature classes. And then your mission is going to be to use this data in ArcGIS Pro to answer 2 specific questions. And here they are. The first question is, which national park in the 48 contiguous states is furthest from a U.S. city with a population of 200,000 or 20,000 or more? Which national park is, so I guess you could say that this is a question about how isolated are the national parks and which one is the most isolated by this metric, the furthest away from a U.S. city with a population of 20,000 or more. And then the second question, which I think is the more interesting question, this is, how many people live within 50 miles of the Appalachian Trail? How many people live within 50 miles of the Appalachian Trail? All right, so we're going to take a look, and then what's, I'm still solidifying the nature of what you're going to submit, but I'd like you to make a layout of your final result, and you have 2 specific answers. Like, there's an answer to this. Which national park? There's an answer. Is it Acadia? Is it Smoky Mountain National Park? Is it Shenandoah? And there's a specific answer. So now the interesting thing is there is, well, the first question, there's really one best way to answer that question, okay? And with the second question, there's a couple different ways that you can answer that, and it's because you're trying to quantify people, and people are, like, everywhere, and it's so you have some choices, like, how are you going to quantify how many people live nearby? And one way is that you could use census tract data, like is used in the laboratory workbook for LA County. You could use something that's much more coarse, like state population, and then do a portioned assignment of that population to within 50 miles of Appalachian Trail. And another approach would be to use county level data. And there's probably other approaches as well. So that third approach, the data I'm going to give you guys is county level data to answer that question. So there'll be a number. There's an answer to this. And depending on the approach you take, your number might be a little different than someone else's number. And that's okay, as long as the approach that you take is sound, okay? And the reason that you might get a different number is because, again, population is a number that is it's not attributed to one location. It's a diffuse property that can be characterized, quantified in different ways. All right, so that's a brief outline of what I'm going to have you guys do for the second practical. And the format will be the same as before. You'll come in the lab and do it. You'll have 2-hour block. You'll sign up for one of the blocks of time and come in, unless there's a really good reason. I'm gonna have to do it this way this time. There's a really good reason why you can't come in to do it, and then we'll deal with that on an individual basis. Okay. All right. So let's go to ArcGIS Pro, and I'll show you what some of this data looks like. So, and let's do a little brainstorming, okay? Might as well, a little brainstorming. So, Um, I'll post some questions and you guys answer them in the comments. All right. So one of the questions is, all right, let's pull this. I'm going to give you these three feature classes to use in your data analysis. NPS boundaries, that stands for National Park Service boundaries. So this is all the lands administered by the National Park Service. And so you click in here, you got the national park, like Yellowstone National Park, and then this, what's this? Badlands National Park, what's this? Great Sand Dunes National Park, what's this? Craters of the Moon National Preserve. So this isn't just national parks. Mojave National Preserve, what's this? White Sands National Park, Petrified Forest National Park, what's this? Missouri National Recreation River. Okay, so we got different, there's a recreation area, national recreation area. Let's zoom in here and see what else we got. So there's Shenandoah National Park, and here, Appalachian National Scenic Trail. So you got all kinds of different designations of National Park Service administered facilities. If you look at the attribute table, that information is in a column called unit type. So you look at unit type, we got, this one's just called park. Where is that? American Memorial Park. Where the heck is that? It's in Mariana Islands. Okay. National Historic Site, National Monument, National Historical Park, historical site. Let's sort descending. Let's see. Got National Scenic Riverway, National Scenic Trail. So that's Appalachian Trail is a National Scenic Trail, and there's another one called Ice Age National Scenic. I've never heard of that. Where's that? It's in Wisconsin. Okay. National Seashores, Parkways, Scenic Recreation River, Wild and Scenic Rivers, National Seashore, National Preserve. Here we go. National Parks. Then we have National Monuments. All right, so here's your first question. You need to answer, right? The question that I posed to you is, which national park is the furthest from a city with at least 20,000 people, population of at least 20,000 people? So what are you going to have to do? And actually, you can say, what you'll have to do, but what tool would you use to take this data that I gave you, which is all of the boundaries of all of the areas administered by the National Park Service, in order to focus in on just the features that represent national parks? What are you going to have to do? What tool would you use? What would you do? I can think of, well, there's at least two ways you could do this. You could accomplish this. Let's see what you know. What do you know? What do you do? Alexis says you could use a query. Yeah, so that's one thing you could do. So you could go to here in the properties, and you could do a definition query. So you could query this layer and return only those layers that have, well, let's not do what you actually have to do. Let's do a query for state, and then you could figure out, let's find just the things that are in Colorado, but you could query by unit type and make that national park. And then what you get is it filters out everything except for the things that meet your query. Okay, so this is what you would do. You would query by unit type and get the national parks. Can anybody think of a different way? One of the shoot. Here we go. Let's remove that. Okay. Can anyone think of a different way? So then you could do, with a query like that, you filter out what you just need, and then you can operate upon just what is still remaining. So if you apply a geoprocessing tool to that layer, the tool will only be applied to the features that are still showing, still visible on that layer. So anything that is removed by the query, the definition query, that data is still in your geodatabase, but it's not operated upon. All right. So one thing you could do, let's say that you did like a, you did an export feature. You use the data management tool for export feature. Only those features that still remain would be exported to the new feature class. What else? Can anybody think of another way? This is fun. I'm actually making you use your brains. So just sitting here showing you stuff. Come on, you guys know this. What's another thing you could do? You need a clue? So what do you call that table that shows all those properties of all those features? What's that table called? It's called a something table. That, you right click on the layer and you could say, click here, and it shows you a table of all these things associated with the features on that layer. What is that called? Attribute. Yes, Cam, thank you. Sorry, there's a delay here, right? So it's an attribute table. Okay, so unit type, which is like National Preserve, National Historical Park, National Park. That's an attribute. That's an attribute that is in a column called unit type. All right, so how could you, there we go, Alexis got it. So you could use select by attribute. So you could come up here and do, oh wait, I gotta switch over. Select by attribute. So we're gonna select something in national park boundaries, a new selection. Let's add an expression. So let's find all the things that are in region northeast, and you can stack these factors. And is unit type equal to let's try national battlefield, see if this gives us anything. And it did. So we got, let's zoom to selection. Oops. Sorry. Look at the attribute table. Let's show just, so there's two features in this data set that meet that those criteria in selection by attribute. Okay. And Whoops, I just undid it. All right, I guess I'll do it again. Select by attribute. Let's do something a little different. Let's find all of the PW, what do you think that's called? Pacific West? All the features in the Pacific West where the unit type is equal to national park. Let's see if we found anything. Yep, okay. So we selected all of the features that meet those criteria by attribute. Okay. And now if I perform use a geoprocessing tool on that layer, it'll be applied only to the things that are selected. Okay, so if I did an export feature or a copy feature, or add a buffer, or any geoprocessing tool, it's only going to be operated on the things that are selected. All right. All right. So let's look at some of the other data that I'm going to give you. All right. So this, when we're going through this, you should have, this should be inspirational to you. You should start thinking about how you're going to solve these problems and answer these questions. So if there's a question about national parks, and the data has that data, but also a bunch of other stuff, right? This data has the data about national parks, but it's also got a bunch of other stuff that you're not interested in. Right? You gotta, well, how are you gonna manage that? What are you gonna do? How are you going to focus on just the national parks? All right, you should know that. And we just showed you at least 2 ways that you could accomplish that. All right. So the other part of this question is, well, national park that is near a major city. So I better give you city data. And I got some data here for you. For that, I got this feature class U.S. major cities. They're not polygons, they're points. Okay, they're just points. If you're looking at all the U.S. major cities, points are probably appropriate. Yeah, let's change the base map to something different. Okay, so each of these dots is a U.S. major city. You can start to see spatial patterns. This is, what's this city right here? That is, let's go to the attribute table. What? There's no name on the cities? Okay. Huh. Well, we don't really need a name for the cities. Interesting. What if I deleted that by accident? Well, what we need to answer a question is population. So actually, this data set gives us population for 2 years, 2010 and 2015. So if you're answering a question, you probably want to use the most recent data you have available. All right, so the 2015 data. And I mean, you look at this data, you can see there's, the answer to this question is probably not going to be, like here, Shenandoah. Shenandoah National Park. It's probably the answer. This is probably not going to be the most remote national park. Here is, well, this town only has 18,000, but it's like a stone's throw away from Washington, D.C. All right, and like all of these. Oh, that's interesting. So Washington, D.C. isn't Wow. I'm going to click on this one right there. I can't select it. So this is a major city, Washington, D.C. It has 674,000 people, so it's probably not Shenandoah. You look at, other national parks. Um, Yellowstone is much more remote. Glacier is pretty remote. It's out here. But it's close to this population center with over 20,000. So you could come up with some guesses visually about which national park is furthest away. But what geoprocessing tool could you actually use to quantify? Well, let's think about this. Maybe we won't know the name of the tool right away, but you think about what spatial relationship are you looking for? If you want to figure out, the question you want to answer is which national park is the furthest away from a city with at least 20,000 people, what do you have to calculate in order to answer that question? What do you gotta do? Okay, Cam says distance. Right. So you're gonna have to calculate a distance. But you think about what you're gonna do. Okay, it's like multi-step here. You have these two data sets, but they're both bigger than they need to be. And what I mean by that is the data set that contains the national parks has other stuff too, right? So you're going to have to filter that out in some way. And then this other data set that's got these U.S. cities that has the population value, it has, there's cities in there which are smaller than your criteria. I gave you guys a criteria. I said furthest from a city with at least 20,000 people. So some of these cities don't have 20,000 people. So there's another criteria. Okay, so you're going to have to do some pre-processing, conditioning of your data before you proceed. And then the question is, well, of those dots that remain on my map, and of those parks that remain, you're going to have to find the nearest dot to each park, right? Because that's what's going to answer the question. I'm really giving a lot away here. But being able to do this is more challenging. So, my goal over the next 3 weeks is not with this data, but with other data sets, the things that we haven't, that you need to be able to do in order to answer this question. If we haven't done it a lot, several times, we'll do it, okay? And so you got to have this in your mind. If I'm going through an analysis and I do something, if you're thinking about the questions you're going to answer, you're going to be like, oh, that applies. I can use that same technique to answer the question that's going to be posed to us in the practical. All right, so you got to pay attention for that. All right. What about let's look at this other data set I have. Okay. So the other data set I'm going to give you is a data set which is all the counties. So here, that's where I grew up, Lancaster County, Pennsylvania. It's got a population of 546,000 people. All right. And here is Berkeley County, 116. Jefferson County, 58,000 people. Whoops. Okay. So the population of these counties is given to you, and if you want to find, okay. So let's not go into too much detail here, but I want you to think about this a little bit. So the other question I posed to you is, I want you to estimate how many people live within 50 miles of the Appalachian Trail. So what kind of geoprocessing tools might you use to answer that question? So the data that you have you'll have a polygon for the Appalachian Trail, and then you've got this feature class which is polygons for all of the counties, and each county, one of the attributes is the population for that county. So what tools could you use? What could you use? Alexis is chiming in with, and Kyle. So Alexis says you can use a 50-mile wide buffer, then calculate the population within the buffer. Sounds easy, right? So yes. So that's one approach you can take. Kyle says buffer zone. Yeah. So you gotta be careful there, because you're like, well, how are you going to calculate the what tool would you actually use? So the buffer tool, okay, I got that. But what tool would you actually use then to add up the populations of all of the counties that are within 50 miles of the Appalachian Trail? And what happens if you got your 50-mile line and it bisects a county? What do you do then? Do you count it? Do you count that county? Do you exclude it? Do you count it partially but not completely? Is there a right answer? Will it matter what you do? Well, it will, but will it be significant? So here, all right. So here's an interesting thing, though. Okay, so the analyses that we've done so far have been on like polygons that are relative. Like we've added buffers to points. We might added buffers to. Oh, we added a buffer to a river. So that was a line feature, and nothing too computationally intensive. But let me show you something here. All right, and this will be a lesson in why. Well, let me do it, okay? And let's I could be wrong here about this. So this is the Appalachian Trail. So let's not do that. Let's do something different. What's this up here? This is Lake Roosevelt National Recreation Area. Okay. So I mean, you look here. The Appalachian Trail is like 20 times longer than this feature up here. And here's another one. What's this? This is St. Croix National Scenic Riverway. So let's do this one. This is pretty long too, but it's not nearly as long as the Appalachian Trail. So if I come in here though, but if you look at it, it's a complicated geometry. Look at all those corners. All right, let's zoom in on the. It's not quite as complicated as the Appalachian Trail, though. The Appalachian Trail, this got overlapping things. That's the Blue Ridge Parkway, and there's the Appalachian Scenic Trail. So, I mean, look at the complexity of these edges. Okay, let's see if ArcGIS can. What do we got down here? Here's another scenic highway, I think. Yes, another scenic parkway. Let's just go up here and let's see what ArcGIS does if I. Here, we'll go to this one. I'm gonna try to apply a buffer zone to the scenic riverway. Lake Roosevelt National Recreation Area. Okay, I'm gonna add a buffer to that. So what I'll do is I'm just gonna select that one feature, and because I don't want to add a buffer to everything, and go into my tools, analysis tools, proximity, buffer, and my input is National Park Service boundaries, but it's just going to do this one selected feature, and we'll do geodesics shape preserving method, no dissolve. Yes, full will include the polygon itself as part of the buffer, and let's do 50 miles for my buffer. Okay, all right, so I'm going to run it and let's see how long it takes. All right. It's trying. Boy, is it ever going to finish? Oh man. It's still going. It doesn't show signs of ever being done. I'm running my, here at my home computer. This is a 6-core. It's a machine that's got a processor in it with 6 physical cores, 12 logical cores, which means it's threaded. It's got 12 threads. It's got a an NVIDIA GTX what is it, 1070. It's like a really good GPU. It's got like 16 gigs of RAM. It's got an SSD hard drive, and it's also got another solid state hard drive, which is even faster, NVM. I don't remember what this interface is called, and it is choking. It's choking on trying to find a buffer for this one little stinking polygon. Look at it. It's still trying. It can't do it. I stop it. So will it ever find the buffer around that polygon? Maybe. But you're not going to be able to do this. Sean says time to upgrade Dr. Groff. I don't know. I mean, this is this is a problem that is not that uncommon. You have. I mean, the geometry is really complicated, and you think about well, what is a buffer going to do? It's going to calculate one way you could do is you could every point draw a 50-mile circle around it, and do that for every point, and then connect all the intersecting points of all those circles, or the maximum extent, of all those circles. And the reason it's complicated is because this geometry has a lot of vertices. It has a lot of line segments connected. So when I am faced with problems like this, and this is a real physicist approach to a problem, it's the approach that you take is that, well, maybe you don't need all that complexity. maybe I don't need to know every single vertex on this polygon in order to, accurately describe its shape. But this is important for the problem I want to answer. And the problem I want to answer deals with being able to draw a buffer that's 50 miles around this feature. And the buffer is much bigger. 50 miles is much bigger than the dimensions of the feature itself. If I zoom in here, at least I'm assuming it is here. Let's zoom in here. So let's measure geodesic meter distance in miles. How far across? So this whole object, this whole feature is less than 2 miles across. This recreational lake, and that's at like its widest point. So you have a situation where you're trying to if you zoom in here, it's like, do these little twists and turns really matter when it comes to trying to encapsulate how many people are within 50 miles? Not really, because these little twists and turns are just like these little teeny tiny distances. All right. So here's the tool you can use if you're faced with a situation like this. You select this again here, make sure everything's clear, and just select this one feature. There's a geoprocessing tool called, let's see, where would it be? Maybe data management? No. I could search for it. I know what it's called, but I like to poke around a little bit. Forget it. I'll just search for it. Simplify. Simplify polygon. Oh, it's in the cartography tools. Okay. So I'm going to take this input feature and I'll output it. You got some different parameters here for options here for the simplification algorithm. We'll just use the default. The simplification tolerance. Let's make it like 0.1 miles. Okay, or let's make it 0.2 miles. Something. It's still. If we simplify our feature so that it's only accurate to within 0.2 miles, that's still going to be pretty good considering the buffer we want is 50 miles. 50 is a lot bigger than 0.2. I'll make it even smaller than 0.1. Minimum area to preserve. Well, let's preserve anything let's keep everything. Collapse points. I don't think we want this. What's collapse points? Yeah, if something collapses to nothing, it'll keep a point for it now. And so let's run it now. Done. Look at that. I'll turn off the other. So here it is. That's the simplified geometry. Let's change colors here. I'll make this. I'll just make the simplified geometry a black outline, and then make this a little bit transparent. Okay. And maybe that's too transparent. That's 100% transparent. There we go. And clear all selection. Okay. So you can see, all right, so the black outline is my simplified representation of the pink thing. And it's pretty much the same, but when you zoom in really close, look how much more simple it is. You go from here to here instead of following that crazy complicated line. So macroscopically it looks almost identical though. When you zoom out sufficiently, it looks almost exactly the same. Okay? But when you zoom in, you see that you're actually... Oh, great. Come on, computer. It's spinning. Drawing. I'm choking here. Again, I'm zooming in and out too much. All right. But when you zoom in, you see that the feature is incredibly simplified. But at the scale that we're interested in, you know, within 50 miles, it looks identical. Okay. So now let me do the buffer, apply the buffer tool again, but I'm going to apply it to this simplified version of my feature, and it should be done much faster. Should be done. I don't know why my thing is choking here all of a sudden. Paul's drawing. And here, let me save this. I might have to X out here. My computer's chugging away for some reason. Alright, I'm going to X out. It won't let me X out. I shouldn't have X out. I should have just tried doing it. All right, well, we'll do that next time. We're out of time, but the thing I wanted to do now is I want to do the buffer tool, but apply it to the simplified geometry. But because, yeah, it's simplified microscopically, but if you zoom out, it looks identical. So when you calculate the buffer around this simplified geometry, it should happen a lot quicker because it's a lot simpler. Less vertices, less line segments. But the end result is going to be essentially the same. You know, at that scale, 50 miles, the end result is essentially the same. So I will say that you will have to do that. You will not be in the time frame that you have to do the analysis on the Appalachian Trail. You will not be able to do that analysis by calculating a buffer around the native feature. You won't. It'll take, I don't know, it might take days to calculate that buffer. But if you simplify first, you can do it quickly. All right, so that's it for today. I'll see you guys on Wednesday, and I'll open this up and we'll calculate the buffer just to show you that it's quick on this simplified geometry, and then we will look at ArcGIS Pro, and I'll show you how to do a density and a heat map. Is that what they call it? With the same things that we did with McDonald's locations on ArcGIS Online. I'll show you how to do that in ArcGIS Pro. And that's chapter 8 material. All right.